Welcome to the Planet of Maths channel. In today's episode, we'll talk about congruent triangles, that is, identical triangles, and about how to recognize if two triangles are congruent. We have three main triangle congruence theorems. This is the first one. Two triangles are congruent if the sides of one triangle are equal to the corresponding sides of the other triangle. This theorem is called side-side-side, in short SSS. This is the simplest theorem of triangle congruence. Two triangles are congruent if they have the same sides. If in one triangle I have sides A, B, and C, then in the second triangle I also must have sides A, B, and C. Then the triangles are congruent. For example, if we have a triangle with sides 3, 6, and 7, and in the other triangle we have sides 3, 7, and 6. So these triangles are congruent by the side-side-side theorem. And even if 7 and 6 were to swap places, we would still have sides 3, 6, and 7 in this triangle. These sides are the same as in the other triangle, 3, 6, and 7. And that's all about the simplest first theorem of congruence. The second theorem of triangle congruence. Two triangles are congruent when two sides of one triangle are equal to the corresponding two sides of the other triangle, and the angles between these sides in both triangles have equal measures. We call this theorem side-angle-side, in short SAS. And this theorem of triangle congruence works in such a way that if I have side A and side B in one triangle, let's mark them in red. And between them is the alpha angle, creating a compact arrangement of two sides and the angle between them. If we find the same thing in the second triangle, the triangles are congruent. In our second triangle, if I have angle alpha here can be side A, here can be side B. This creates a similar compact arrangement of two red sides, A and B, with the alpha angle included between them. If the arrangement is the same in both triangles, then these triangles are congruent. This congruence would be ruined if one of these sides, for example if side A was taken from here and moved here. Then, indeed, we would have sides A and B, but angle alpha would not be included between them. Then the triangles wouldn't be congruent. They're only congruent if A is here and B is here, or vice versa. From this second theorem of triangle congruence, we can determine if these two triangles are congruent. Looking at the first triangle, here we have a setup like this. There's a side of 9, a side of 8, and an angle between them of 40 degrees. So we have this compact arrangement. And in the other triangle, we also have a side 8 and a side 9. But a 40-degree angle isn't included between these two sides at all. If there were a 40-degree angle here, these triangles would be congruent. But in this case, these two triangles are not congruent. What about those two triangles? Are they congruent? We have a 7, we have a 6. In the second triangle, there is also a 7 and a 6. So, the sides do match up for us, but the angle is a bit off, because in the second triangle, between the 7 and the 6, we have an angle of 50 degrees. And in this triangle, we have a 7 and a 6, and the angle between them, we don't know it. So, for now, at least, we can't say whether these triangles are congruent. But if we know the angle is 70 and another is 60, then we can figure out how many degrees there are here, because all angles in every triangle add up to 180 degrees. So we subtract these two angles from 180 degrees, so 70 plus 60 equals 180 minus 130, and this is 50 degrees. This means we have a 50-degree angle here. And that fits us, because now we have a compact system of two red sides, 6 and 7, and an angle between them of 50 degrees. In the second triangle, there's a red 7 and a red 6, and in between them a green angle of 50 degrees. An identical compact arrangement is in this triangle and in that triangle, which means these two triangles are congruent by the side-angle-side theorem, meaning SAS. And now about how the third theorem of triangle congruence works. It goes like this. Two triangles are congruent if one side of a triangle is equal to a side of the other triangle, and two angles adjacent to these equal sides in both triangles have equal measures. This theorem is called angle-side angle, also known as ASA. Here, we'll need two angles and one side. Just like in this picture, we have one side, and the angles alpha and beta adjacent to it, they must necessarily be next to the alpha side. In this triangle, I have such an arrangement. And in the second triangle, I have exactly the same setup. Here is side A, and the angles alpha and beta correspond to it. Here we have an angle-side angle, and here we also have an angle-side angle. So, these two triangles are congruent. Can we now determine that these two triangles are congruent? In the first triangle, we have angles of 60 and 40 degrees, and we have a side that is 8. In the other triangle, we also have angles of 40 and 60 degrees, and a side of 8 as well. But let's look here at the red side 8. The angles of 60 and 40 are as if they're attached to it. 60 and 40 are attached to 8. Over here to the 8, well, maybe it's attached a 40-degree angle, but definitely not a 60. So, for sure, these two triangles are not congruent based on the angle-side angle theorem. Means ASA. These triangles would be congruent if that 8 wasn't here, but instead, if we had that 8 over here, then those would be congruent triangles with angles of 40 and 60 degrees attached to this 8. And just like here to this 8, angles 60 and 40 would be attached. However, when the 8 is here, these triangles are not congruent. Can we now say that these two triangles are congruent, meaning identical? We have here an angle of 65 degrees. We have two sides equal to 12 in one triangle, and in the other triangle, we have a side of 12 with two angles attached to it, 50 and 65. From our angle-side angle theorem, it turns out we should have one side and two angles attached to this side, something like what we have here. Here we have a side of 12, and attached to it are angles of 50 and 65. We would need to find the same arrangement in the other triangle. Do we find such an arrangement here? We have side 12, but we have only one angle attached to it. So, it seems that this is a bit too little, but there are other clues here that will allow us to determine whether these triangles are congruent or not. Here we have 12, and here we have 12 as well, which means this triangle is isosceles. If two sides of a triangle are equal in length, then the angles opposite them are also equal. This means if it's 65 degrees here, it's 65 degrees there too. Thanks to this, we can now calculate what measure is this angle. Simply subtract the two angles together from 180 degrees, which is 65 plus 65. It's going to be 180 minus 130. After adding this and that, it eventually equals 50 degrees. This means we have a 50-degree angle here. Now, let's check. To the red side of 12, we have angles of 65 and 50 degrees attached. It's exactly the same in this triangle. To the red side of 12, an angle of 65 and 50 degrees is attached. It's the same arrangement here and there. Thus, these two triangles are congruent by the side-angle side, or SAS theorem. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.